Okay, so now on to some more examples here where we get a little bit more complicated denominators. But again, I see a trinomial, right? And I want to say, can I factor this? Like, should this be factorable? And more times than not, you're going to see a lot of these patterns are going to, a lot of similar patterns are going to arise. I'll just keep it like that. So as I go ahead and factor this, I say, oh, well, this kind of gets factored to x minus 3 times x plus 1. Which, hey, is the exact same as my other two denominators, right? So rather than trying to multiply all three of these, I realize that my LCD in this case is just the product of these two binomials, which is already the denominator over here. So a quick little step here, like I've been doing the same thing, like multiply everything times the LCD, but hopefully maybe you've understand this point, is when I multiply everything times this LCD, this x minus 3 divides out, leave me just with an x plus 1. The x plus 1 will divide out, leave me just with an x minus 3. And in this case, the x minus 3 and the x plus 1s are going to divide out. So let's just write, I'll do that maybe. Yeah, let's just write out. So therefore, let's just multiply everything times x minus 3 times x plus 1. Right? So therefore, x minus 3 is divided out, so I'm left with a 1, basically, times x plus 1. You don't really need to write the 1. Then I have a negative 2. X plus 1 is divided out, so I'm left with just a x minus 3. And then over here, I'm left with a 2x times x minus 3 times x plus 1. No, I'm sorry, I'm just left with a 2x, right? Those got divided out. Okay, so now I can again just simplify this, get rid of by applying distributive property. So I'm with an x plus 1 minus a 2x plus 6 equals a 2x. So therefore, this becomes a, a negative x plus 7 equals a 2x. Add an x, 7 is equal to a 3x. Divide by 3, switch it over, x is equal to 7/3. Now, in our previous examples, we had some integers. So now we have a rational function, so it's going to be a fraction. But again, I can kind of very quickly see that by plugging in 7/3, I'm not going to get to 0 into any of my problems. So we're looking good here, all right? Now let's go ahead and apply the exact same thing. Same operation here. I want to see this is factorable. And again, I kind of quickly see that this is factorable to the product of my other two denominators. So when I go ahead and multiply this, again, the same really process is going to apply. When I multiply my common denominator times everything, whatever is my denominator is going to divide out with my LCD. So this is x minus 3 times x minus 4. I'll just write in there. So for housekeeping rules. Okay, so therefore I'm going to be left with now 3 times an x minus 4 plus 5. The x minus 4s will divide out here, so I'll be left with 5 times an x minus 3, and then equals a x squared minus 20. So now what we have is our first quadratic equation, right? Because I don't have everything simplified yet, but you can see that my highest power of my degree is 2. So that means I'm going to have 2 solutions. And whatever my solutions are, I'm going to want to make sure that I check them into my denominator to make sure they don't make my denominator equal to 0. So let's go ahead and simplify this. And then remember, solving quadratics is a little bit different than solving linear equations. So I'm either going to have to solve by factoring or by the quadratic formula. All right, so let's go ahead and group our terms here. This is going to be an 8x. That'd be a minus 27. So therefore, I have an 8x minus 27 equals x squared minus 20. Now, it's also important when you have multiple variables, like the linear variable x and the x squared, is we're going to want to set this equal to 0 to go ahead and solve. So I'm going to subtract an 8x, and I'm going to add a 27 to both sides. Therefore, I'll obtain a 0 equals x squared minus 8x, and then I add a 27, that's going to be a plus 7. Okay. However, I see that this is factorable, so 0 equals a x minus 7 and an x minus 1. Okay, and then use the zero product property, set them both equal to 0. I get x equals 7 and x equals 1. Now, again, we want to check our solutions. And you can see, though, if I plug a 7 or a 1 into any of my denominators, you can see that they both work. So even though I had a possibility of another extraneous solution, I did not have one. So we're looking good. All right, so now let's just kind of get into one where, again, we have these variables, coming up with us. And I thought I had another one. I guess not, maybe not. Okay, so you could use, in this example, go ahead and do the cross multiplication. That's perfectly fine. But again, what I want you to see is if I need to get this 5x minus 6 off the bottom, all I'm going to do is multiply by 5x plus 6 on the left and the right side. Right? So therefore, I'm left with 10x plus 3 is equal to a 5x plus 6 divided by 2. And then I need to get this 2. I want to undo dividing by 2, so I'm going to multiply by 2 on both sides. And all I want you to see is that gives me, make sure you put that in parentheses, you're multiplying it 2 times that whole expression. So it's a 20x plus 6 is equal to, those divide out, 5x plus 6. Okay, so you're going to get the exact same. So, the cross multiplication is multiplying this times this and that times that. But if students will make mistakes, it's often because they just make them, they don't understand why cross multiplying works. So that's why I prefer to just get whatever is off your denominator as your variables, just using your inverse operations. Now what I can see here is I can subtract the 6 on both sides, and I'm just left with a 20x equals 5x. So again, subtract the 5x on both sides, and I get a 15x equals 0. Divide by 15 on both sides, and you can see x is equal to 0. Now again, you say, oh, it's extraneous because it's 0. But again, does x equal 0 make my denominator equal 0? And the answer is no, because you plug 0 in for x, you get 5 times 0, which is 0, but plus 6 is going to be 6. So therefore, it still satisfies our equation, and it is a solution. Just be careful here. Again, when I multiply by 2, make sure you're just using parentheses. That's a very big mistake people will make. All right. In this next example, now I could use some inverse operations here. If I wanted to, I could get the 4 and the 10 combined because they're both integers. But I'm just going to go with this thing. I don't like x's in the denominator. So I realized that if my denominators are 1x, 1 and x, then my least common denominator is just going to be x, and I'm going to multiply just everything times x. Everything. Every single term times x. And whenever x is in the denominator, it's going to divide out with x. So therefore, I'll be left with a 10x minus 13 equals a 4x plus 5. So hopefully I don't need to show my work in each case. But again, if you wanted to, this one's not as bad. Let's just do it one more time. So again, you're multiplying the x, your LCD, times everything. So that's 10 times x minus 13 over x times x equals 4 times x plus 5 over x times x. So again, these x's are in the numerator, right? So you can see that is why my x's divide out there. That's why I can just write it as 10x minus 13 equals 4x plus 5. All right, so now I'm just going to get my variables to the left side and get my numbers to the other side. So if I subtracted a 4, I would get a 6x, and if I added a 13, equals 18. So I just divide by 6 on both sides, and x is equal to 3. Okay, so I'm kind of skipping some steps, obviously, for the sake of time. On this next one, well, I could multiply everything times x minus 2, and that's perfectly fine. But why don't I just subtract a 1 or subtract a 2? Why don't we just get that over? So therefore, I have a 2 over x plus 2 is equal to a 1, right? Now, you could think about this as again, another fraction. But again, if I just want to get that off the denominator, I'm just going to multiply by an x plus 2 on both sides. And cool thing is, now those divide out. I'm just left with 2 equals x plus 2. So then I subtract a 2, x is equal to 0. And then it comes into, does that make sense? Like, does I plug 0 in? Is it a good solution? Yes. And I can even check this solution. Like 0 plus 2 is 2. 2 divided by 2 is 1. 1 plus 2 is 3. And like you can see, it works out. And I did forget to check this solution as extraneous. Obviously, the only denominator is 3. So if I was to plug 3 in for x, you could see that would not be extraneous. So we're good to go. All right. So now let's get into ones where we have to really identify the LCD. So in this case, we have 2x plus 1 and 2x minus 1. So they look very similar, but they're not exactly the same. So again, the easiest way to understand the LCD is the LCD is going to be a multiple that both x plus 1 and x minus 1 divide into. And again, the easiest way to do this, if they don't already share something, is just to multiply them. So I'm not going to write it all the way out. I'm just going to write it as the product. 2x plus 1 is times 2x minus 1. So basically the product of them is always going to give us our LCD. And again, if I want to get rid of that product, I'm going to, or get rid of them in the denominator, I'm just going to multiply everything times the LCD. Okay, so when I multiply this, you can see my 2x's plus 1s will divide out. So I'll be left with a 7 times 2x minus 1. Make sure you're here. I'm going to have a negative. My 2x minus 1s will divide out. So I'll be left with a negative 8x times 2x plus 1. And then here, I don't have a denominator in this case. So therefore, it's going to be equal to a negative 4 times the 2x plus 1 times 2x minus 1. All right, so eventually we're going to have to multiply these out. But let's go ahead and apply some distributive property here. And then we'll just expand that. So this is going to be a 14x minus 7 minus 16x squared minus an 8x is equal to, now I'm going to do this one other time because this is a difference of two squares. So that's going to give me a 4x squared minus 1. And I got some work over here. I got to simplify. So let's go ahead and rewrite this in descending form. So this is negative 16x squared. 14x minus 6x is going to be a positive 6x minus 7. And therefore is equal to a negative 16x squared plus 4. Well, that's cool because now you can see that these are on the same. If I add these to both sides, they are going to go to 0, right, if you add a 16x squared on both sides. So therefore, I just have a 6x minus 7 is equal to 4. And then if I add a 7 to both sides, 6x is equal to 11. Therefore, x is going to equal to 11 over 6. Okay, and again, we can go back and check our work, plug that back in there, and we can see that it is going to work. It's not going to make the denominator equal 0. So far, our quests for our extraneous solutions have not shown up, but guess what? They're going to come in the next 6 videos, or the next 6 problems.